Yeah, okay, thank you. See here, Ohm's law is very, very important because in each and every application, we use the Ohm's law to calculate the voltage and current. So how to state the Ohm's law? Before discussing about the Ohm's law, we defined a current. Yeah, see here. This is a conductor which is having number of electrons, and we connected a battery. We applied a voltage V here. What I told that, so electrons are flowing in this fashion, but the current is flowing in this direction. Okay. Now I can model, this is a copper conductor. Listen carefully. This is a copper conductor. And every material has its own resistance. We can model this copper conductor into what? Resistance. So indirectly it is a copper conductor. You can model that copper conductor into a resistance. So you can convert the circuit into like this. Plus and minus voltage V and current I is flowing. After doing so many experiments, Ohm scientist, and it is a resistance R. Indirectly, this resistor represents the what? A copper conductor property. So according to the Ohm's, what is the statement he gave? He states that voltage V across a resistor is directly proportional to the current I flowing through the resistor. What is that? Voltage across resistor. Voltage across resistor means some voltage drop will be there. Some voltage drop will be there. This is voltage drop. So there are two different ways they can state. One way is the voltage drop across this resistor is proportional to the current. That is the one definition. That means the drop across this resistor, voltage drop will be there because it opposes the flow of electrons. Some voltage drop. Voltage drop means suppose it is a 20 volt source. Some drop may occur. This may be 3 volts like that. That is a voltage across the resistor. Is directly proportional to that current I. That is the one statement he gave. Another statement is the current flowing through the particular resistor is proportional to the voltage. That is another statement. So the statement states that voltage V across a resistor is directly proportional to the current I flowing through the particular resistor. That is the statement. Very, very important. They may ask for short answer questions. So this V is directly proportional to the I. V is directly proportional to the I here. And the proportionality constant is replaced by some property called resistance. Okay? That is V equal to R into I. Where, what is the R here? R is the what? Resistance of the circuit, which includes a copper conductor as well as a connecting wires. Okay, na? That is the meaning of circuit resistance. Circuit resistance. So V equal to R into I. R into I is the mathematical representation of Ohm's law. So many times you'll use V equal to R into I. Okay, no? Where R is the resistance of the circuit, which is measured in ohms. We already discussed. Okay, and V is the applied voltage in volts. Okay, what is that applied voltage here? Applied voltage is the supply voltage. So in this example, we applied a 20 volts. Okay, that is the V applied voltage. And I is the current. What are the units for the current? Amperes, which is measured in amperes. Okay, and the important point in this Ohm's law is it is defined at constant temperature only. The temperature should be kept constant. Then only the voltage across the resistor is proportional to the current. This is valid only when at constant temperature. If the temperature changes, what will happen here? The number of electrons are increases in the conductor, because I already said that the outer shell electron is having higher energy level. Whenever you apply a heat energy also, the electron may come out of the valence shell. Once the electron is come out of the valence shell, it will act as a free electron, and if that free electron is moving in a particular conductor, current will be increases. That is the effect of variable temperature. Okay, at that time this condition may not holds good. This condition holds good only when, see, at constant temperature. So whenever you are writing Ohm's law, you start with at constant temperature. At constant temperature, yeah, voltage V across a resistor is directly proportional to the current I flowing through the resistance. Okay, that is the statement of the Ohm's law. Okay, so, and from this formula we can V equal to R into I, V equal to R into I. Sometimes they will give a voltage, applied voltage and current I. Then they want to ask calculate the R value. R equal to, from this you can write V by I. That is one formula. Next, other formula is we can write I equal to V by R. I equal to. So those things are formulated in the picture here. So which says, see here, in this diagram, Ohm's law pie chart here. V equal to, we can write R into I. That is the one thing here. Okay, and I equal to V by R. Okay, that is another thing. And R equal to V by I, such that we can remember. Okay, so when you want to calculate the resistance, we can write V by I here. See here, if you close R with your palm, then we can find R equal to V by I. R equal to what? V by I. And if I want to calculate I here, then I equal to what? V by I. I equal to V by I. This is the current. అక్కడ వస్తుంది సార్, మొబైల్ డేటాతో చెప్తున్నాను, బట్ అక్కడ మీకు ఫుల్ ఛార్జింగ్ ఉండాలి, లేకపోతే ఇది యూజ్ చేస్తే మీకు పవర్ కన్జ్యూమ్ అవుతుంది, మిడిల్లోనే ఆఫ్ అయిపోతుంది. సి హియర్, if I want to calculate the V, okay, then what is this V? V equal to multiplication of I into R. So in the pie chart, these pie charts are used to remember these formulas. This is about the Ohm's law. Okay, no? So anybody have any doubts, you can ask here. Any doubts, Amma? Please respond. $134, 19134, are you there? Prasanna, 108, 20 series.
Yes, sir.
Yeah. Can you state the Ohm's law, Amma? Can you state the Ohm's law? Mohana Deepthi, 19125.
Yes, sir.
Yeah, can you state the Ohm's law, Amma? At a constant temperature?
Yes, sir. It is voltage across the resistor and it is directly proportional to current I.
Very good. So that is what is the mathematical expression? Mathematical expression 101 20101. Srishalama.
V is equal to Rs.
V equal to Ri. Very good. So this formula you will be using so many times for calculation of. They will give two values on two known values. We have to calculate unknown value in a particular circuit. So we will be using this formula so many times while calculating the current in a particular circuit. Okay. So this is about the Ohm's law, statement of Ohm's law. And after stating this, yesterday we discussed about the what mean by branch, node and loop. Node is a point of interconnection between the two or more branches. Okay, na? And the loop is a closed path in a circuit. A branch is a element, particular element. It may be a voltage source or a resistor. So once if you know these basics, we can go for KCL and KVL, Kirchhoff's voltage law and Kirchhoff current law. So let me state these two things. Later I will stop the class here. Kirchhoff current law. It is known as a first law, first KCL. Kirchhoff's law. This is the first law. That is Kirchhoff current law. Okay. What is the statement here? The statement is the algebraic sum of the currents entering a node. See, a node, you have to remember the node here. Or a closed boundary is equal to 0. Okay, what is the meaning of this here? I will give a practical example here. Is there any space to write here? Yeah. Suppose if I take a circuit, a simple circuit I am taking here, which is R1 and resistance R2, and this is resistance R3. The voltage V is applied here, so current is I is flowing. I is flowing through each and every element. So this direction of I is this. Once the current is comes here, and again it is dividing in this path and in this path. So these currents are different. I can say this is I1 current, and the current which is flowing through this R3 is, let us say, I2, and the current which is flowing through R2 is I3. And you can say this is a node, right? Node is a interconnection of these branch segments. Okay, na? Now come to the statement here. Come to the statement. The algebraic sum of, what do you mean by algebraic here? Algebraic sum means we have to consider the polarities or signs, plus sign or minus sign. That is the meaning of algebraic sum of the currents entering at a node. Entering at a node is equal to 0. That is the one statement. In another way also we can state the algebraic sum of the entering currents are equal to leaving currents. Okay, in that way also we can define. But in this, the algebraic sum of the currents entering at a node is equal to 0. So I will come to this one later after explaining this equation. See here, if you take this node, let us say this node N, at this particular node, can you guess what is the direction of the current? For current, compulsory you should give a direction. This current is entering towards the node. Okay, na? What about these two currents? I2 current and I3 currents. I2 current and I3 currents. From this node, what is the direction? It is away from the node or towards the node? Pranay, please respond. Pranay, are you there on 106?
Sir, yes, sir.
Yeah, what is the direction of these two currents, I3 and I2? These currents are leaving or entering towards the node? See, direction of arrow.
Sir,
Direction of arrow is away from the node or towards the node?
towards the node, sir.
టువార్డ్స్ ది నోడ్ ఎట్లయితే నాన్న ఈ డైరెక్షన్ ఎట్లా ఉంది కదా I2 ఎలా ఉంది away from the node కదా that means we can say the current is leaving or entering current is entering or leaving the node
Leaving, sir. Leaving
very
the
good
node.
ఈ కరెంట్ ని లీవింగ్ కరెంట్ అంటే ఎందుకంటే దిస్ arrow is away from the node అంటే ఇలా ఉంది and I3 also leaving
Okay.
leaving. Now what about the I1 current? I1 current is at a particular node. I1 current is what? Entering current. Which current? It is a entering current. So how many algebraic sum of all currents? I1 current is there, I2 current is there, and I3 currents is there. You know? So algebraic sum means some of these currents are going to be 0, but you should consider the sign convention should be there. For that we can use plus and minus symbol, plus symbol and minus symbol. If the current is entering, okay na? If the current is what? Entering, we can use minus, that is our Visham. Minus. In some of the textbook, they will use minus, and some of the textbook they are using plus sum. And these currents are I2 and I3 are currents are leaving. Leaving means plus and I3 plus and 1 plus. Okay, this is the meaning of algebraic sum. Okay, this is the meaning of the algebraic sum. So minus I1 plus I2 plus I3 equal to 0 is the mathematical representation of the KCL. Okay. So as we are running out of the time, I stop here. In next class, again I will start with the KCL and KVL. After discussing KCL and KVL, you will solve some basic problems.